we have two helicopters here. One of them is hovering and the other one is flying along at a horizontal velocity of 20 meters per second. At the same moment, they drop their packages and we see projectile motion. But the point we want to make is that vertically, the projectile that follows this parabolic arc vertically is staying lined up with the projectile that fell straight down, and horizontally it stays lined up with the helicopter above it, all of this ignoring air resistance. It's easier to see this if we watch it happen one frame at a time. So let's look at that. One frame at a time, we see that the moving helicopter drops the package at the same moment as the hovering helicopter. And as each tick of the seconds pass by, the falling projectile is still lined up with the one that's falling straight down, and it's still directly beneath the helicopter that dropped it. And this is true even if the projectile were launched at an angle. So let's look at that. I'm going to change the launch angle. So now the helicopters that drop these things, one of them is flying straight up and one of them is flying up at an angle of 18 degrees, but they have the same upward component. Let's watch the whole thing and then we'll look a frame at a time. Okay, now let's look at it one step at a time. In the first instant, the helicopter on the left is just rising. The one on the right is rising and moving to the right. So you'll notice that vertically, both packages initially move upward, and then due to the acceleration, due to gravity, they slow down, stop, and begin their downward path. But during the entire motion, the blue projectile also continues with the horizontal velocity of the helicopter that dropped it. Even when the helicopters are out of the screen, the diagram tells the whole story.